Our next presenter is Renata Kotynia. Renata Kotynia is Deputy Dean for Development at the Faculty of Civil Engineering, Architecture and Environmental Engineering at the Lodz University of Technology. She is also the head of the Department of Concrete Structures. Renata is an active member in several international organizations, including the FIB, in particular in Task Group 5.1. So the presentation of Renata is about FRP jetting, and I will ask Renata as soon as she's ready to start the presentation. Thank you, Renata.
Good morning, everyone. It is my great pleasure to present today the topic of my presentation. Let's start to introduce the chapter very briefly. The chapter 3.12, FRP jacketing. This is the summary of the schedule of this chapter. At the beginning, I will describe the materials, the different techniques of strengthening, and in the last two items, I will show two case studies. Let's start from the FRP jacketing methods, which are adopted to mainly to increase the shear capacity, beams, columns, walls, beam columns, joints, against the static or dynamic loading, increased the concrete compressive axial strain activity, especially for the columns, for the confinement, and retrofit the certain cases of columns with bars under compression in order to prevent the buckling. Another several points based on the increase of the capacity of the tensile zones, especially for slabs, beams, under static and dynamic loadings as well. The increase the capacity of the columns against the blast loads, strengthening due to suffering the earthquake conditions, and the protecting of the existing concrete elements against the environmental and induced steel corrosion. Especially, this is dedicated for the harsh environments. Benefits of this technique, especially this is high strength to weight ratio, makes the structures jacketing with the negligible added thickness not increase much higher weight to the structure, and not added very big thickness to the original section. It doesn't significant dead load to the structure, especially it doesn't increase the load-bearing demands. It maximizes the net floor plan area, especially if it is applied to the vertical members. It provides easy to handle reinforcement, and which can be followed due to the different kind of form, shapes of the existing members. Let's start with the information about the continuous fibers. Here you can see, I will show, here you can see variable materials referring to the fibers made of carbon, glass, ceramide, basalt, and other fibers. They are mainly different with the elasticity modulus and the tensile strength. What is the most different in this reason is the different inclination of this material of those fibers, and especially different ultimate strain. So it means that the most stiff are carbon fibers, but the lowest, due to the lowest elasticity, the maximum strain of those fibers, the glass fibers have a very low inclination, so very low elasticity modulus. However, the ductility is very big. Another, I would like to describe a little bit types of adhesives, especially for that adhesive to which the manufacturer of the adhesive should specify. The first is adherent materials, maximizing application temperatures. The curing temperatures are very most important. The surface preparation techniques, pot life, open time and shelf time, and glass transition is the main factor dedicated to this adhesive. Thermal expansion, creep properties, and abrasion and chemical resistance. The next type of FRP materials in these techniques are matrices. So what is the most important? That in first, the matrix can be considered as the anisotropic material, especially for the structures which are strengthened with polymer or thermosetting thermoplastic type of matrices. Another thing is refers to the matrix, which gives protection to the fibers against abrasion or environmental corrosion. The epoxy resin, polyester or vinyl ester resins are mainly common for the polymeric matrix, which are used with the high performance reinforcing fibers. Another topic is dedicated to the thermosetting polymer, which makes good processability and chemical resistance. And the last one refers to the polyesters and vinyl esters, which are much cheaper than the previous one. Let's move to the FRP strengthening systems. The first one is FRP jacketing. Externally bonded FRP materials consist on several techniques and especially consists on the large number of continuous directionalized fibers with advanced characteristic bundle in a polymeric matrix. This technique is typically good for the volume fraction of fibers in FRP systems, which equals different volume of fraction of fibers for strips. This is between 50 and 70% for the sheets and fabrics, 25, 40, 50%. Let's move to the mechanical properties of the existing materials. Especially, I would like to show you the differences between the materials, because in the previous table I showed just only the types of the elasticity modulus of fibers, but here this is the typical elastic modulus for the fibers, tensile strength, but existing FRP elements. So it seems that the elasticity modulus is lower. Tensile strength is a little bit lower, but due to different volume of fibers and friction, it can be vary. And there is the strong relationship between the fibers and the volume of friction. This is comparison between the fiber volume for 100%, 700%, and 100% for different thickness of the of the materials. So here you can see for the different cross sections area different properties of the FRP elements, especially in reference to the failure load. This is the comparison for the strips with thickness 0.7 millimeters, 1 millimeters, 1.4 millimeters, and thickness and the width 100 millimeters. Going to the next strengthening system, the cured in situ system. This is the dry unidirectional no woven fiber sheet and woven and nightened fabric. They are placed on site and saturated, made by saturation of the sheets, fabrics with the specific resin. So there are two different processes which can be used to apply the sheets and fabrics on site. The first is the sheet fabric is applied directly into the resin uniformly onto the concrete surface, and this is dry technique. And the pre-impregnated fiber toes, shorts, tapes, or rods, which are twisted or maybe wounded or mechanically placed on the concrete surface. And the last is the textile reinforced modal techniques, which is mainly used for the fire protection. I will talk about it later. The procured prefabricated elements can be installed typically through the use of the adhesives, and this application can be applied with mechanical fasteners or without. If it is important, the powder activated nails or bolts can be used. So for the strips, the form of the strips can be thin ribbons, rods, grids, which can be delivered to the roll coin or pull-through strips. For the pre-stress applications, CFRP straps are wrapped around the special sandals at corners should be applied. The pre-cured shaped shells, jackets, or angles can be installed through the use of adhesives. And the curve of shape elements, splits, or shells can be fitted around the column elements. Here is the basic of the FRP techniques. The first one is hand lay up CFRP sheets. Here you can see the manual application of the sheets around the externally reinforced columns, and they can be applied directly to the surface with fibers possible to the direction in the process. The fibers can be moved on the horizontal direction, or even in several cases it can be in diagonal applications. Another technique typical with this one is the prefabricated shell. So it is applied. The aim of this application is to increase ductility, especially for the fibers which are typically placed on the hoop direction. Here you can see. Another technique is automated wrapping, which on this picture it is visible that the continuous winding of the wet fibers is applied. Especially it is applied for the columns, sometimes for the chimneys as well. And the key advantage of this technique is that apart from the good quality, because of the shaping and proceeding of this pre-stressing, slide pre-stressing, it is a very rapid installation. And let's move to the cementitious fiber reinforced cementitious mortar, FRCM, which is applied for FRP stranding, which suffers some problems associated with epoxy resin. Here you can see that especially for the inorganic binders, it is very important. Another thing is that the bond condition in this cementitious composite is improved by the replacement of the textile. So not the sheet are applied by textiles or multiply applications in different directions. Here the pictures of those. Another very interesting technique for pre-stressing is FRP jacketing by pre-stress jacketing. And it can be applied as a laminated, not laminated straps, like here, and laminated straps. It is basically applied for the shear strengthening of the CFRP pre-stress jacketing beams, webs, box guiders, as you can see on this slide. However, it is very common for jacketing, strengthening with pre-stress confinement, jacketing of the columns. In reference to the old codes and standards, I applied a lot of the reference in this chapter. However, in this, I would like to focus just only on the codes and standards, not on the literature. Here you can see we used for this chapter FIB Bulletin number 90. This is the last one, which was published 3 years ago. FIB Bulletin 35, which based on the retrofitting of concrete structures by externally bonded FRP. And I used additional some information from the ACI, IC's design strengthening reinforced concrete structures, CNR regulations, and the recommendations from the Japanese code. And now I would like to move to the case of study. The first one is Selenota's twin bridges strengthening located in Akia, Greece. It was, the designer was the constructor, PC contractors and Anchor. And here you can see the initial application of the sheets. It was the TIFO fiber wrap, which was applied for the bearing capacity of main grinders. Here you can see this application in some parts of concrete slabs, decks, and additionally it was used for strengthening of the shear strengthening, enhancement of the shear strengthening as well. And this bridge was strengthened with the total area of concrete repaired place was 3,000 square meters, and approximately 13,000 square meters of the FRPs were applied in addition to 4,000 composites, fibers, anchors. and the length of each anchor was 400 millimeters, and 2000 meters of the near surface mounted strips were applied here in this bridge as well. Another case of study is the seismic rehabilitation of the bridge guiders. This is in South Italy with FRP and steel reinforced polymer, and the location was the highway Salerno Reggio Calabria bridge, and the designers were the client was ANAS, contractors Kogit Brinzi, and here you can see that this quite innovative technique of rehabilitation based on the combined using CFRP and CRP means steel reinforced polymer spikes, which were applied in order to increase the structural performance under both gravity and seismic loads. So here the spikes were placed in order to increase the bearing capacity of the RC piers here, and ends without enlarging their cross sections were additionally applied on the vertical, on the horizontal part of those columns were applied CFRP reps. Here you can see made of jacketings. So this is the CFRP spikes. The spikes were located in the appropriate holes here, you can see, drilled into the beam foundation, and then the in order to ensuring this bond length, which was 300 millimeters in the foundation and 550 meters at the beam, it was additionally CFRP. Those CFRP spikes were applied with additional CFRP sheets in order to prevent those spikes for the buckling due to the cycling loads. So from my side, thank you very much. If you have any questions, I'm ready to discuss.
Thank you very much, Renata, for your nice presentation. I'm seeing here a question from Simon Tomai. Well, it's not really a question. I think it's more a comment, but maybe Renata, you can discuss this. So Simon Tomai says, in real situation, the column is already supporting loads. If we drill a high number of holes to install the dowels, we are reducing the concrete section, and the loads redistribute over the reduced section, increasing the stresses. The strengthening works can potentially overstress the structure that needs to be strengthened. Can you comment on this?
Yes, obviously it is good information from Simon, but it depends how large is the strengthening. Because if it is not very large, so the reduction of concrete section is not so big problem. It depends what is the strengthening, what is the kind of strengthening.
Okay. So maybe if you want to a more detailed answer, Renata, you can proceed on the answering typing your more detailed answer if you want. So we have here two more questions. One from Alexandru Trandanfir. and it says, are the vertical FRP strips anchored to the top edge in the bridge girder case? The effect of FRP debonding could limit the effectiveness of the strengthening solution.
Very good questions. Thank you very much. There are several different techniques of the anchorage. Mainly, it can be drilled through the slab and applied on the top side. But in this chapter, there are no any additional information about it. Yes, about the technique of the FRP strips anchorage, especially for the bridges. However, this effect of FRP bonding is very effective for the strengthening. So in different applications, it is important to apply, especially for the shear strengthening, because I mean that it refers to the shear strengthening. But if not for the externally bonded on the bottom side of the guider, it is possible to apply additional anchorage systems, or for the shear, additional steel anchors, or some bolts inside to increase this technique.
Okay, so we have lots of questions. So another question from Abdul Jaudet. The CFRP reinforcement in the previous bridge doesn't endure vacuum thrust.
The CFRP reinforcement in the previous bridge doesn't endure vacuum thrust. But could you a little bit?
Well, maybe you can skip this question and you can chat with.
Okay, I will chat it. Okay,
I'm seeing lots of questions.
I will ask Abdo for what is the main topic of this question.
Not acceptable at all, the question. So another question from Manus Mathiudakis: is the FRP strength always limited by the adhesive resin?
As I introduced in my presentation, there are not limited adhesive resins, because there are, just for now, we have in one table, in the big table, I described all different types of the resins. So here you can introduce inside, and what I can suggest to review the FIB Bulletin 90, because there are a lot of different types of resins specified in this bulletin. So I specifically would like to introduce to revise the FIB Bulletin 90.
Okay, thank you, Renata, once again. So from Karel van Hand, has there been a lot of research regarding the FRP protection the concrete from environmental substances, or should we mainly be used for structural strengthening?
This protection refers to the question is, what does it mean, environmental substances? Because it depends mainly on the type of environmental conditions, because it depends if they are chlorates or other ingredients. So this is mainly dedicated to apply the specific resin to the specific environmental substances. This is the answer.
Okay, thank you. So we have one more question from Firas Shalash.
Yes,
yes,
I can see.
okay.
I can see this question. What about the fire protection? Yes.
Yes.
I suggested in one slide that the most effective technique for fire resistance is application of mortar and application of the fibers, not the resin, because resin, the glass transition of the resin is very low. So in order, if it is important to apply this technique of strengthening for the fire protection, so the mostly recommended is the using of mortar with the grad.
Okay, so we have just one more question, but I think it's similar to this one, but maybe you want to give a more detailed answer. Mm-hmm. So it's from Maynard Oliver Gonzalez. Sorry if I'm not spelling correctly all these names, but he wants to know, how do we protect CFRP from weathering, fire, and other external effects, and how many layers are allowed for CFRPs?
The number of layers depends on the how big is the increase of the capacity. This is the answer. But the second one is that it is possible to apply additional protection, not only the mortar fibers, but additional protection. If this additional protection is applied, then there is the fire protection is fully safe.
Okay, so I will give just one more question to Renata. It's from Vengat Egade. Normally bridges are designed for 100 years. Does this FRP repair service life is for 100 years also?
Yes, this is absolutely true, because especially CFRP is very is not non-sensitive to the environmental condition, and another thing, the adhesive. So the smallest time for is due to concrete. The small long time is due to concrete, but the sheets due to the application of the adhesives, it highly increase the time of the loading. So I think that 100 years is absolutely prospective.
Okay, Renata, thank you very much for your nice presentation and for answering all these questions. I also like to acknowledge the audience for all these questions.